For 31 hours in late May of 1941, the most powerful warship ever built was invisible. The Royal Navy had lost her. The entire British home fleet was searching in the wrong direction. And somewhere in the vast gray expanse of the North Atlantic, a German battleship was racing toward safety, leaving behind a trail of devastation and over 1,400 dead British sailors. The admirals in London were frantic. Churchill himself was demanding results every hour. Every available ship had been thrown into the hunt. Battleships that should have been protecting convoys were racing across the Atlantic. Aircraft carriers were launching search patterns that covered thousands of square miles. And yet the Bismarck had simply vanished into the endless gray wilderness of the North Atlantic. Then, on the morning of May 26th, a lumbering aircraft that many experts had already dismissed as obsolete spotted a dark shape cutting through the waves 700 miles from the coast of France. An American at the controls, a pilot who was not even supposed to be there because his country was not yet at war, radioed the position. Within hours, the most dangerous warship in the world would be crippled and doomed. The aircraft was a Consolidated PBY Catalina flying boat. Aviation experts had called it slow, ungainly, and outdated before the war even started. The man who designed it had spent years fighting skeptics who believed his flying boats had no place in modern warfare. His name was Isaac Macklin Ladden, and the machine he created would help change the course of history. This is the story of how an engineer from New Jersey built an airplane that the experts dismissed, only to watch it find the most feared battleship on Earth when nothing else could. It is a story of genius, persistence, vindication, and the strange way that wars are sometimes won not by the fastest or the strongest, but by the aircraft that can simply stay in the air longer than anyone believed possible. In the spring of 1941, Britain stood alone against the full might of Nazi Germany. France had fallen in just 6 weeks the previous summer. The Soviet Union remained bound by its non-aggression pact with Hitler, supplying Germany with vital resources, while the Wehrmacht consolidated its conquests across Europe. The United States was still officially neutral, its citizens bitterly divided over whether to enter a European war that many believed was not their concern. Britain's survival depended entirely on the convoys of merchant ships crossing the Atlantic from North America. Every week, dozens of freighters carried food to feed a population that could not sustain itself. Tankers brought oil to fuel the tanks and aircraft of an army still rebuilding from the disaster at Dunkirk. Cargo ships delivered weapons, ammunition, raw materials for industry, and everything else an island nation needed to keep fighting. If those convoys stopped, Britain would starve within months. Everyone understood this, most of all, the Germans. The German Navy had made strangling Britain's supply lines its primary mission. The U-boat fleet under Admiral Karl Donitz was growing larger and more effective every month. His wolf packs roamed the Atlantic, sinking hundreds of thousands of tons of shipping with increasing efficiency. But the submarines were not the only threat. The German surface fleet, though smaller than the Royal Navy, possessed warships of terrifying power. And none was more terrifying than Bismarck. The battleship Bismarck represented the pinnacle of German naval engineering. Launched in 1939 at Hamburg to enormous fanfare, she displaced over 50,000 tons fully loaded, making her one of the largest warships ever constructed. Her main armament consisted of 8 15-inch guns in 4 twin turrets, weapons capable of hurling shells weighing nearly a ton each to distances of 20 miles or more. Her armor protection was the thickest and most sophisticated ever installed on a warship, with a belt of hardened steel up to 12.5 inches thick protecting her vital machinery. Most importantly, Bismarck was fast. Her powerful engines could drive her through the water at over 31 knots, faster than almost any other battleship afloat. This meant she could choose her battles, engaging enemies she could defeat, and running from superior forces. In the vast reaches of the Atlantic, where convoys crawled along at 10 knots and their escorts were often worn-out cruisers and destroyers, Bismarck could strike with devastating effect and then vanish before help arrived. The British Admiralty understood exactly what Bismarck's entry into the Atlantic would mean. A single battleship operating freely could tie down the entire home fleet, forcing warships that should be protecting convoys to hunt endlessly for a phantom that could be anywhere across millions of square miles of ocean. Meanwhile, the convoys would sail without adequate protection, and the U-boats would feast. Against this threat, Britain deployed everything it had. But finding a single ship in the vastness of the Atlantic required eyes that could see far beyond the horizon. It required aircraft with extraordinary range and endurance. It required flying boats. And it required the PBY Catalina, the aircraft that Isaac Ladden had spent a decade perfecting, while skeptics insisted his creation was already obsolete before it ever flew into combat. Isaac Macklin Ladden came into the world on Christmas Day, 1894, in Garfield, New Jersey. His family lived in modest circumstances, neither wealthy nor particularly notable. Young Isaac showed an early aptitude for mechanical things, for understanding how pieces fit together to make complex machines work. He possessed the kind of mind that could visualize solutions to problems that stumped others, the rare ability to see in 3 dimensions what existed only as concepts on paper. He pursued his education at McGill University in Montreal, studying engineering with the intensity of someone who knew exactly what he wanted to do with his life. The theoretical foundations of aerodynamics and structural mechanics fascinated him. But what truly excited Ladden was the application of theory to practical problems. He wanted to build things that flew. When America entered the First World War in 1917, Ladden joined the United States Air Service, assigned to the Experimental and Engineering Test Center at McCook Field in Dayton, Ohio. This was where the military tested new aircraft designs, pushing machines to their limits to discover what worked and what killed pilots. Young engineers like Ladden were thrown into an environment of constant experimentation, where yesterday's breakthrough could become today's disaster if the calculations were wrong. Ladden thrived in this high-pressure environment. His talent for solving complex problems quickly attracted attention from senior officers. He demonstrated an unusual combination of theoretical knowledge and practical intuition, understanding not just what the mathematics predicted, but how materials actually behaved under stress. Within just 2 years of arriving at McCook Field, at the remarkable age of 24, he became the chief of design for all large aircraft development. He was responsible for overseeing the creation of the biggest and most advanced flying machines America could build. But the armistice in November of 1918 ended the urgency that had driven military aviation forward. Funding dried up. Promising projects were canceled. Many of the brightest engineers left government service for the growing commercial aviation industry. Ladden remained for several more years, but he increasingly felt constrained by the bureaucratic slowness of peacetime military development. He was also an inventor at heart, constantly sketching new ideas, filing patents on aerodynamic innovations and structural improvements. His notebooks filled with drawings of aircraft that existed only in his imagination, machines that pushed beyond what anyone else thought possible. He held patents on aircraft wheels, brakes, and numerous aerodynamic and structural developments. The work was intellectually stimulating, but Ladden wanted to see his designs actually built and flown. In 1927, Ladden made the decision that would define his career. He left government service to join the Consolidated Aircraft Corporation as their chief engineer. The company's founder, Reuben Hollis Fleet, had ambitious plans to make Consolidated a major force in American aviation. He needed an engineer who could design aircraft that would dominate the competition. He found exactly what he was looking for in Mac Ladden. Fleet was a former Army aviator with boundless energy and supreme confidence in his own judgment. He had served as the first officer in charge of the United States Airmail after the war, and later as contracting officer for the Army Air Service. He understood both the technical requirements of aircraft design and the business realities of selling to military and commercial customers. He and Ladden formed an unlikely partnership that would prove remarkably productive. The two men could hardly have been more different in temperament. Fleet was gregarious, charming, always selling something to someone. He handled the business side of the company, wooing customers, securing contracts, and making deals. Ladden was quieter, more reserved, most comfortable at his drafting table or walking the factory floor. He translated Fleet's ambitions into actual aircraft that worked. They clashed frequently on details, but together they would build one of the most important aircraft manufacturing companies in American history. When Ladden arrived at Consolidated, flying boats represented the cutting edge of long-range aviation. The simple reason was infrastructure, or rather, the complete lack of it. In the late 1920s, there were almost no concrete runways anywhere in the world. The only concrete runway in the United States was at Floyd Bennett Field on Long Island in New York. Even the most advanced airports used grass fields or compacted gravel, surfaces that could not support heavily loaded aircraft, especially in wet weather. But water was everywhere: oceans, lakes, rivers, harbors. An aircraft that could land on water needed no runway at all. It could operate from any coastline, any sheltered bay, and any body of water large enough to allow a takeoff run. For airlines trying to establish long-distance routes, flying boats offered the only practical solution. For navies needing to patrol vast oceans, they were essential. The United States Navy was particularly interested in long-range flying boats. They needed aircraft that could patrol vast stretches of the Pacific Ocean, searching for enemy fleets, protecting the approaches to Pearl Harbor and the Philippines, bridging the enormous distances between American bases scattered across thousands of miles of island chains. They approached Consolidated with a challenging specification. They wanted a flying boat with greater range, speed, and payload than anything that existed. Ladden threw himself into the project with characteristic intensity. His first major flying boat for the Navy was designated XPY-1, which they called the Admiral. It was a metal twin-engine monoplane, revolutionary for its time because previous Navy flying boats had used multiple engines mounted on struts and biplane wing configurations. The Admiral first flew in January of 1929. It was the first monoplane flying boat for the United States Navy, a significant achievement that established Consolidated as a serious competitor in the field. But Ladden knew the Admiral was only a beginning. He immediately began working on improvements, incorporating lessons learned from each test flight into the next iteration. The process of refinement became almost obsessive. Every flight generated data. Every landing revealed new stresses on the hull. Every hour in the air taught the designers something they had not known before. Through the early 1930s, Ladden refined his flying boat designs relentlessly. The commercial Model 16 Commodore provided data on long-distance passenger operations. The military P2Y series for the Navy pushed range and performance further than anyone had achieved before. In February of 1933, 6 P2Y aircraft flew non-stop from San Francisco to Pearl Harbor, Hawaii, covering over 2,500 miles across open ocean in just under 25 hours. It was a stunning demonstration of what long-range flying boats could accomplish, and it captured headlines around the world. But Ladden was already looking beyond the P2Y. He envisioned a flying boat that would surpass everything that came before, an aircraft so advanced that it would remain the standard for maritime patrol for decades. In his notebooks, he sketched designs that incorporated every lesson he had learned since arriving at Consolidated. The wing would be cleaner with internal bracing instead of external struts. The hull would be more efficient, balancing seaworthiness with aerodynamic demands. The engines would be more powerful and more reliable. In October of 1933, the Navy issued a specification for a new patrol bomber with a range of 3,000 miles and a cruising speed of 100 miles per hour. It was an ambitious target that many considered unrealistic. The Navy invited both Consolidated and Douglas aircraft to submit competing designs. Ladden designed what would become the most famous flying boat in history. Have you ever worked on a project that everyone said was impossible, only to prove them wrong? I would love to hear your thoughts in the comments. The prototype XP3Y1 incorporated innovations that had never been combined in a single aircraft. The most striking feature was the massive parasol wing mounted above the fuselage on a central pylon. Unlike earlier flying boats that used forests of external struts and wires to brace their wings, Ladden's design used internal bracing. The result was a dramatically cleaner aerodynamic profile that reduced drag significantly. Even more innovative were the stabilizing floats. All flying boats need some way to keep their wingtips out of the water during takeoff and landing. Previous designs used fixed floats attached to the wings by struts, adding weight and drag that penalized performance. Ladden designed floats that retracted upward to become part of the wingtips themselves during flight. The mechanism was complex and added maintenance challenges, but the aerodynamic benefits were substantial. The hull was a masterpiece of hydrodynamic engineering. It had to perform contradictory functions. In the water, it needed to act like a boat, stable and seaworthy, able to handle rough conditions. In the air, it needed to produce as little drag as possible. Laddon shaped the hull with careful attention to both requirements, creating a form that pilots would come to appreciate for its forgiving handling both on water and in flight. The aircraft that emerged from Consolidated's factory was unlike anything the world had seen. When it first took to the sky on March 21, 1935, pilots and engineers alike recognized they were witnessing something special. The Douglas competitor flew first, beating the Consolidated design into the air by more than a month. But the Navy's evaluation clearly favored Ladden's creation. Both designs met the specifications, but the Consolidated aircraft was significantly less expensive at $90,000 per aircraft, and its performance was slightly better. The Navy designated it PBY, with PB standing for Patrol Bomber and Y being the manufacturer code for Consolidated. They ordered 60 production aircraft, the largest peacetime order for military aircraft in American history to that point. The British would later give the aircraft the name that stuck forever. True to their tradition of avoiding alphanumeric designations for their aircraft, the Royal Air Force named their PBYs Catalinas, possibly suggested by Consolidated President Reuben Fleet after Santa Catalina Island off the coast of California. The name was eventually adopted by the United States Navy as well, and it is the name by which the aircraft is remembered today. But not everyone was impressed. By the late 1930s, aviation technology was advancing at a furious pace. Sleek new monoplane fighters like the Supermarine Spitfire and the Messerschmitt Bf 109 were appearing that could fly 3 times faster than the Catalina. High-performance land-based bombers were being developed that made the slow-flying boats look like relics from an earlier age. Military planners increasingly focused on speed and altitude as the measures that mattered most in modern warfare. At Consolidated, even Fleet and Ladden began to question whether the PBY had reached the limits of its development. By 1939, they believed they could not significantly improve the design further, and that it was time for an entirely fresh approach. Hitler's invasion of Poland erased this notion. With war in Europe, production of existing proven designs suddenly became far more important than developing theoretical replacements. Many aviation experts openly questioned whether flying boats had any future at all in modern warfare. The criticism stung Ladden, who believed passionately in his creation. He continued to refine and improve the design, adding more powerful engines and improved equipment with each new variant. But the skeptics grew louder. The Catalina was slow, with a maximum speed of barely 180 miles per hour. It was ungainly on the water and in the air. It belonged to a passing era. By the time war began in Europe in September of 1939, many considered the PBY obsolete before it had even seen combat. They were profoundly wrong. What the critics failed to understand was that the Catalina possessed qualities that no other aircraft could match. It could stay in the air for over 20 hours at a stretch. Its maximum range exceeded 2,500 miles, allowing it to cover enormous distances that no land-based aircraft could manage without refueling. It was extraordinarily tough, able to survive damage that would destroy more fragile machines. Its rugged construction meant it could operate in harsh conditions that would ground more delicate aircraft. And it could operate from any body of water, requiring no airfields, no runways, no elaborate ground infrastructure. In a war that would range across oceans where bases were few and far between, this capability would prove invaluable. These qualities would matter enormously in the desperate days ahead. The German battleship Bismarck sailed from Gottenhafen in occupied Poland in the early hours of May 19, 1941, following the heavy cruiser Prinz Eugen, which had departed the previous evening. Prinz Eugen was a powerful warship in her own right, with 8-inch guns and a top speed exceeding 30 knots. Together, they represented a devastating threat to everything afloat in the North Atlantic. The operation was code-named Rheinübung, Exercise Rhine. The plan called for Bismarck and Prinz Eugen to break out into the Atlantic through the Denmark Strait between Iceland and Greenland. Once in open water, they would scatter across the convoy routes, attacking merchant shipping while evading the Royal Navy forces that would inevitably pursue them. The strategic goal was to strangle Britain's supply lines at a time when U-boat successes were already pushing the island nation toward crisis. Admiral Gunther Lütjens commanded the operation from Bismarck's bridge. He was a veteran naval officer who had successfully commanded previous raiding operations, including the sortie of the battlecruisers Scharnhorst and Gneisenau earlier that year. He understood both the capabilities of his ships and the risks they faced. The Royal Navy remained the most powerful naval force in the world, and if concentrated against Bismarck, it could overwhelm even the most formidable battleship. British intelligence learned of the German movement within days. A Swedish cruiser spotted the German ships transiting the waters between Denmark and Sweden on May 20th. The information was passed to the British naval attaché in Stockholm, Captain Henry Denham, who immediately alerted the Admiralty in London. The Royal Navy was not caught by surprise. On May 21st, a daring RAF reconnaissance pilot named Flying Officer Michael Suckling flew his Spitfire over the Norwegian fjords where the German ships had anchored near Bergen. Flying at 26,000 feet to avoid the fighters circling below, he photographed Bismarck and her escorts. The images confirmed the nightmare that British naval planners had feared. Bismarck was preparing to break out into the Atlantic. The Royal Navy mobilized with desperate urgency. Admiral John Tovey, commanding the home fleet, put to sea from Scapa Flow with the battleship HMS King George V, the aircraft carrier HMS Victorious, cruisers, and destroyers. The battlecruiser HMS Hood, the largest warship Britain possessed and the symbol of Royal Navy power between the wars, raced to intercept along with the newly commissioned battleship HMS Prince of Wales. Heavy cruisers spread out to watch the possible escape routes through the Denmark Strait and the Iceland-Faroes Gap. Every available asset was committed to stopping Bismarck before she could reach the open ocean. The convoys would have to fend for themselves. Nothing mattered except destroying the German battleship. The Germans chose the Denmark Strait for their breakout, the narrow passage between Iceland and Greenland where floating pack ice and persistent fog might hide their passage. It was a calculated risk. The strait was the most direct route to the Atlantic, but it was also closely watched by British patrol vessels. On the evening of May 23rd, the British heavy cruisers HMS Norfolk and HMS Suffolk, patrolling the Denmark Strait, detected Bismarck on their new radar sets. The German ships were steering southwest at high speed, forcing their way through the scattered ice floes. The British cruisers began shadowing, staying just out of range of Bismarck's guns, while reporting every change in course and speed to the pursuing British forces. Vice Admiral Lancelot Holland aboard HMS Hood calculated an intercept course. He planned to engage Bismarck in the early morning hours of May 24th, bringing his 2 capital ships against the German battleship before she could escape into the open Atlantic. The Prince of Wales was so new that civilian workers from the shipyard were still aboard, struggling to fix problems with her quadruple gun turrets that kept jamming. But there was no time to wait for proper working up. Bismarck had to be stopped. The Battle of the Denmark Strait began at 5:52 in the morning on May 24, 1941. Hood and Prince of Wales closed rapidly with the German ships, eager to bring their heavy guns into action. Admiral Holland chose an approach course that limited his own ship's ability to fire their full broadsides, hoping to close the range quickly where Hood's thinner deck armor would be less vulnerable to plunging shells. The German gunners were ready. The fire control systems aboard Bismarck and Prince Eugen had tracked the approaching British ships with precise radar ranging. Their first salvos were remarkably accurate. What happened next shocked the world. At approximately 6 o'clock, less than 10 minutes after the battle began, a shell from Bismarck struck HMS Hood. It is believed to have penetrated the ship's deck armor and reached one of the after magazines where shells and propellant charges were stored. The explosion that followed was catastrophic beyond imagination. A pillar of flame shot hundreds of feet into the air. Hood broke in half, her bow and stern rising briefly before plunging beneath the waves. She sank in less than 3 minutes. Of her crew of over 1,400 officers and men, only 3 survived. Midshipman William Dundas, able seaman Robert Tilburn, and signalman Ted Briggs managed to escape the freezing water and were eventually rescued. Everyone else, including Vice Admiral Holland, perished. The Prince of Wales, badly damaged by hits from both German ships and suffering continuous malfunctions in her main gun turrets, was forced to break off the action and retire behind a smokescreen. Her bridge had been hit by a shell that killed or wounded nearly everyone there except Captain John Leach. Of her 10 14-inch guns, only 1 or 2 were firing reliably by the end of the engagement. Britain's proudest warship was gone. Over 1,400 sailors were dead, and Bismarck was still heading for the Atlantic, apparently unstoppable. But Prince of Wales had scored her own hits during the brief battle. 3 shells from her functioning guns struck Bismarck, causing damage that would prove crucial. 1 shell ruptured a fuel tank, contaminating 1,000 tons of oil with seawater and causing a leak that left a visible oil slick behind the battleship. Another flooded a boiler room, reducing Bismarck's top speed. The German ship could still fight, but she could no longer operate indefinitely in the Atlantic. Admiral Lutyens made a fateful decision. He would detach Prince Eugen to continue commerce raiding operations on her own, while Bismarck made for the French port of Brest for repairs. Once repaired and refueled, she could resume operations. The mission was not a failure, merely postponed. The Admiralty in London was stunned by the loss of Hood. Churchill himself sent urgent messages demanding action. Every ship that could possibly reach the area was ordered to converge on Bismarck's last known position. Force H under Vice Admiral James Somerville was recalled from Gibraltar and ordered to race north at maximum speed. The old battleship HMS Ramillies was pulled from convoy escort duty. Even the carrier HMS Victorious, with her inexperienced air crews, was thrown into the pursuit. That evening, Swordfish torpedo bombers from Victorious launched a strike against Bismarck. The weather was deteriorating, visibility was poor, and most of the pilots had never dropped a torpedo in combat before. Yet they pressed home their attack with extraordinary courage. 1 torpedo hit Bismarck amidships, but caused no significant damage to the armored belt. And then, in the early hours of May 25th, Bismarck vanished. The heavy cruiser Suffolk, which had been tracking the German battleship on radar for nearly 2 days, suddenly lost contact. Her radar operators watched in frustration as the returns faded and disappeared. Bismarck had executed a series of course changes that broke the radar lock, circling behind her pursuers before turning southeast toward France. The British assumed Bismarck was doubling back toward Germany through the Iceland-Faroes Gap. This seemed logical. A damaged ship would naturally seek the safety of home waters. Admiral Tovey turned his fleet northeast, racing at maximum speed to cut off what he believed was the enemy's escape route. He was heading in exactly the wrong direction. For 31 agonizing hours, the Royal Navy searched in vain across the wrong part of the North Atlantic. The crisis was absolute. Bismarck's fuel situation was still unknown to the British, and for all they knew, the German battleship might still be operating somewhere on the convoy routes. If she reached the protection of Luftwaffe air cover operating from occupied France, she would be nearly impossible to stop. She could make repairs, refuel, and return to sea whenever she wished. British code breakers at Bletchley Park eventually decrypted German signals that confirmed Bismarck was heading for France, not Germany. Admiral Lutyens, unaware that he had successfully shaken off his pursuers, had broken radio silence to send long messages to Berlin. The direction-finding stations of the Royal Navy triangulated his transmissions, but a plotting error aboard Tovey's flagship sent the fleet off course for additional precious hours. By the morning of May 26th, time was running out. Bismarck was less than 700 miles from the French coast. Within hours, she would be under Luftwaffe protection. If she was not found soon, she would escape. At Coastal Command headquarters, officers pored over charts calculating every possible position where Bismarck might be. The only hope lay with long-range aircraft that could search the vast areas of ocean that remained unchecked. They turned to the Catalinas of 209 Squadron, based at Castle Archdale on Lough Erne in Northern Ireland. The squadron had received their Catalinas only recently, taking delivery of the first aircraft in late 1940 and early 1941. The flying boats were still unfamiliar to many of the crews, who had previously operated different aircraft. To help the RAF learn the new American flying boats, several United States Navy pilots had been quietly attached to the squadron as advisors and instructors. Officially, these Americans were just training observers. The United States was still neutral, and President Franklin Roosevelt had promised Congress that American military personnel would not be involved in combat operations. Roosevelt understood that isolationist sentiment remained strong in America, and any revelation that American pilots were flying combat missions could provoke a political crisis that might even threaten his presidency. Among these American pilots was Ensign Leonard B. Smith of the United States Navy. Known as Tuck to his friends, Smith was 25 years old, born in Mayview, Missouri. He was an experienced aviator who had helped ferry Catalinas across the Atlantic and was now teaching RAF crews how to operate them effectively. On the morning of May 26th, he was assigned to fly as co-pilot on a search mission in one of the sectors where Bismarck might be hiding. The aircraft was Catalina AH-545, marked with the squadron code WQZ. It had been delivered to 209 Squadron just weeks earlier, in late April. The pilot in command was Flying Officer Dennis Briggs of the Royal Air Force, a young officer who had already survived several harrowing incidents in his flying career, including a crash landing in Ireland just weeks before. The crew of 8 prepared for a mission that would take them far out over the Atlantic, searching for a needle in a haystack the size of Western Europe. They took off from Lough Erne at 3:25 in the morning, climbing into darkness and following the Donegal corridor that allowed British aircraft to overfly neutral Ireland's airspace under a secret agreement with the Irish government. The weather was atrocious. Low clouds pressed down to just a few hundred feet above the waves. Fog drifted in patches across the gray sea. Rain squalls reduced visibility to almost nothing. It was exactly the kind of weather that made finding anything nearly impossible. For hours they saw nothing but gray clouds and gray sea. The crew rotated through their positions, scanning the water below whenever the visibility permitted, monitoring their instruments, fighting the fatigue that came from hours of monotonous flight through terrible conditions. The aircraft droned on, covering mile after mile of empty ocean. Just after 10 o'clock in the morning, their search sector brought them over coordinates that had been calculated using the best available intelligence about Bismarck's possible course and speed. Ensign Smith was at the controls while Briggs rested. The autopilot was engaged. Through a break in the clouds, Smith spotted something below, a dark shape moving through the water. A ship, a large ship. He immediately took control from the autopilot and dropped the Catalina lower, descending through the murk for a closer look. As the clouds parted briefly, he saw her clearly. A massive warship with a distinctive silhouette, her outline matching the recognition charts they had studied. There was no mistaking what they had found. Smith started a climbing turn to starboard, keeping the ship in sight while gaining altitude toward the safety of the clouds. Briggs rushed aft to prepare a contact report. Their plan was simple. Get into the clouds, approach as close as possible, make positive identification, and then shadow the battleship while reporting its position. Before they could transmit, Bismarck's anti-aircraft guns opened fire. The sky around the Catalina erupted with shell bursts. The slow-flying boat was an easy target, lumbering through the sky at barely 100 miles per hour. Heavy flak peppered the clouds around them. Smith jettisoned the depth charges to lighten the aircraft and threw the Catalina into violent evasive maneuvers, weaving through the sky in desperate S-turns while clawing for altitude. The shells continued to burst around them, shrapnel rattling against the hull. Somehow, miraculously, they were not hit badly enough to bring them down. The Catalina was taking damage, but remained airworthy. From the relative safety of the cloud cover, Briggs transmitted the position report that changed everything. The coordinates placed Bismarck approximately 690 miles northwest of Brest, heading southeast toward France at reduced speed. The position was clear enough for the Admiralty to redirect every available force. The hunt was back on. The contact report from Catalina Z of 209 Squadron electrified the Admiralty. After 31 hours of agonizing uncertainty, they finally knew where their enemy was. But knowing was not the same as stopping. Bismarck was still making for France at 20 knots or more. The home fleet under Admiral Tovey was too far north to intercept before the battleship reached the safety of Luftwaffe air cover. Most of the pursuing forces were low on fuel after days of high-speed steaming. Only one British force had any chance of stopping Bismarck. Force H, racing north from Gibraltar under Vice Admiral James Somerville, was still at least a day away, but was on the right side of the enemy. Its core was the aircraft carrier HMS Royal, with her squadrons of Fairey Swordfish torpedo bombers. The Swordfish was an open cockpit biplane that looked like something from the First World War. It had a top speed of barely 140 miles per hour and a fabric-covered airframe that seemed impossibly fragile for combat. Aviation experts considered it even more obsolete than the Catalina that had found Bismarck, but it could carry an 18-inch torpedo, and it was what the Royal Navy had available. Meanwhile, additional Catalinas maintained contact with Bismarck throughout the afternoon. Despite the terrible weather, despite the intense anti-aircraft fire, the flying boats continued to shadow the German battleship, updating her position for the pursuing forces. 2 other Americans were aboard Catalinas that spotted Bismarck that day, Lieutenant Johnson in an aircraft of 240 Squadron and Ensign Reinhardt in a Catalina of 210 Squadron. The Swordfish crews aboard Ark Royale knew what they had to do. They had to stop Bismarck before nightfall, or she would escape. The weather that afternoon was beyond atrocious. Winds gusted to nearly 50 miles per hour. Waves surged 30 to 40 feet high. The flight deck of Ark Royale pitched so violently that the bow rose and fell through 50 feet with each wave. The first strike of 15 Swordfish, launched at 2:50 in the afternoon, was a disaster. The crews had been given inadequate information about friendly ship positions. They spotted a ship through the storm and attacked it with torpedoes, believing it to be Bismarck. Fortunately, the magnetic pistols on the torpedoes detonated prematurely when they hit the water or ran erratically and missed. The ship was HMS Sheffield, one of their own cruisers that had been detached to shadow the enemy. A second strike was organized hastily, this time with contact detonators on the torpedoes that would not detonate until they actually struck a target. At 7:10 in the evening, 15 Swordfish launched from Ark Royale's heaving deck into winds that howled at gale force. They would attack with just hours of daylight remaining. Their target was less than 50 miles away. The Swordfish found Bismarck as darkness approached, guided by Sheffield to the enemy's last position. They attacked from multiple directions in flights of 3 aircraft, diving through curtains of anti-aircraft fire that filled the sky with steel. The slow biplanes should have been easy targets. The gunners aboard Bismarck could not understand why they were so hard to hit. The Swordfish flew so slowly, often under 90 miles per hour during their attack runs, that the German fire control computers, designed to track fast modern aircraft, could not calculate proper deflections. 3 torpedoes struck the battleship. 1 hit amidships, exploding against the armored belt with little effect. A second hit further aft on the port side, causing flooding but no critical damage. The third hit the stern. It was the luckiest shot of the entire war. Sub-Lieutenant John Moffat, a young pilot from Scotland, is widely credited with dropping the torpedo that crippled Bismarck. Flying barely 50 feet above the waves while the battleship executed a hard turn to port, he released his weapon at the perfect moment. The torpedo struck precisely where the armored belt did not extend, hitting the steering gear compartment. The explosion jammed Bismarck's twin rudders at 12 degrees to port. The mighty battleship, pride of the German Navy, was suddenly unable to steer. She could only circle helplessly in the heavy seas, trapped by a single lucky torpedo from an aircraft that everyone had called obsolete. The Swordfish had accomplished what no surface ship could have done. They had stopped Bismarck. Through the night, British destroyers under Captain Philip Vian harassed Bismarck constantly. They launched torpedo attacks in the darkness, forcing the crippled battleship to maneuver and fight, exhausting her already weary crew and preventing any attempt at repairs. The men aboard Bismarck tried desperately to free the jammed rudders, sending divers into the flooded compartments, but the damage was too severe. Admiral Lutyens sent a final message to Berlin. "Ship no longer maneuverable. We will fight to the last shell. Long live the Führer." When dawn came on May 27th, the battleships HMS King George V and HMS Rodney closed in for the kill. They opened fire at 8:47 in the morning, their 14 and 16-inch shells smashing into Bismarck at ranges where they could not miss. The German battleship returned fire as long as she could, but her gunnery was erratic without proper steering, and one by one her turrets fell silent as shells destroyed them. The final battle lasted less than 2 hours. Bismarck was reduced to a burning wreck, her superstructure shattered, fires raging throughout her hull. At 10:15, the cruiser HMS Dorsetshire fired torpedoes into the crippled hulk. At 10:36 in the morning, Bismarck rolled over and sank, taking over 2,100 of her crew with her. Surviving German officers had ordered scuttling charges set to ensure their ship would not be captured. Only 115 German sailors were rescued from the freezing water before a U-boat scare forced the British ships to depart, leaving hundreds more to drown. It was a brutal end to a brutal chase. The threat was over. The Royal Navy had avenged HMS Hood. Britain's supply lines across the Atlantic were secure for the moment, and it had all begun with a slow, ungainly flying boat that the experts had dismissed as obsolete. What moment in your life proved the experts wrong about something you believed in? I would love to hear your story in the comments below. The Catalina's role in finding Bismarck was merely the beginning. As the war expanded across the globe, Isaac Ladden's flying boats would prove their worth again and again in ways that even their creator could not have anticipated. Just 1 year after the Bismarck chase, in June of 1942, Catalinas of United States Navy Patrol Squadron 44 were patrolling northwest of Midway Island in the Central Pacific. On the morning of June 3rd, they spotted a massive Japanese fleet steaming toward the American base. Their contact reports gave Admiral Chester Nimitz the crucial intelligence he needed to position his outnumbered carriers for the ambush that would destroy 4 Japanese aircraft carriers and change the course of the Pacific War. Throughout the Battle of the Atlantic, Catalinas hunted U-boats with relentless determination. Their extraordinary endurance allowed them to patrol the mid-Atlantic Gap, that vast area of ocean beyond the reach of land-based aircraft where German submarines had operated with near impunity. The flying boats forced U-boats to stay submerged during daylight hours, wasting precious battery power and reducing the time they could spend hunting convoys. When the submarines surfaced to recharge, Catalinas were often waiting. 2 Catalina pilots earned the Victoria Cross, Britain's highest award for valor, for pressing home attacks against heavily armed submarines in the face of withering defensive fire. Flight Lieutenant David Hornell of the Royal Canadian Air Force died after his Catalina was shot to pieces during an attack that sank U-1225. Flying Officer John Cruikshank of the Royal Air Force was wounded 72 times by flak, but continued his attack run and survived. In the Pacific, the Black Cat squadrons painted their Catalinas matte black and flew night missions against Japanese shipping. They slipped in at wave-top height in the darkness, using radar to find their targets, dropping torpedoes and bombs before the enemy knew they were there. These slow, seemingly vulnerable aircraft became feared night raiders, sinking or damaging thousands of tons of enemy shipping and earning a fearsome reputation among Japanese sailors. And everywhere the Catalinas flew, they rescued downed airmen and shipwrecked sailors. The aircraft earned the nickname Dumbo, after the flying elephant in the Disney film. Their ability to land on open ocean swells and taxi to survivors made them the rescue aircraft of choice. Countless lives were saved by Catalina crews who risked everything to pluck men from the sea. By the end of the war, Consolidated and its licensees had built over 3,282 Catalinas, more flying boats than had ever been manufactured of any single type. They served with the armed forces of the United States, Britain, Canada, Australia, New Zealand, the Netherlands, the Soviet Union, Brazil, and Free France. They operated in every theater of the war, from the frozen waters of the Arctic convoys to the tropical islands of the South Pacific. The critics who had called them obsolete were forced to acknowledge an uncomfortable truth. Speed and altitude were not the only measures that mattered in modern warfare. Range, endurance, reliability, and versatility counted for just as much. The Catalina possessed all of these qualities in abundance. It could go where other aircraft could not, stay longer than anyone else, and accomplish missions that nothing else could perform. Isaac Ladden did not rest on the success of the PBY. Even as Catalinas were proving themselves in combat around the world, he was already at work on his next great project. The B-24 Liberator heavy bomber emerged from his design team, incorporating lessons learned from years of flying boat development. It would become the most produced American military aircraft in history, with over 18,400 built by the end of the war. The Liberator served in every theater, from the oil refineries of Ploesti in Romania to the islands of the Pacific. It was never as famous or as beloved as the Boeing B-17 Flying Fortress, but it carried more bombs farther and faster. Military historians still debate which was the better aircraft. What cannot be disputed is that Mac Ladden designed one of the 2 workhorses that carried the strategic bombing campaign to victory. After the war, Ladden continued to push boundaries. He led the design team that created the massive Convair B-36 Peacemaker, the intercontinental bomber that served as America's nuclear deterrent during the early years of the Cold War. With its 6 pusher propellers and later 4 additional jet engines, it was the largest mass-produced piston-engine aircraft ever built. His Convair commercial airliners carried passengers around the world, competing successfully with designs from Douglas and Lockheed. By the time he retired, Isaac Ladden had shaped American aviation across more than 4 decades. His designs had helped win a world war and maintain the peace that followed. He held numerous patents for innovations in aerodynamics and aircraft structures. He had trained and mentored a generation of engineers who would carry his methods forward. But it was the Catalina that remained his most lasting legacy. The flying boat that experts had dismissed before the war even started had proven itself in ways that no one anticipated. It had found the Bismarck when nothing else could. It had spotted the Japanese fleet approaching Midway. It had hunted U-boats across the Atlantic and rescued countless lives from the sea. It had served longer and more widely than any flying boat before or since. The aircraft outlived most of its contemporaries. Military Catalinas continued serving into the 1960s and beyond, with air forces around the world. Some remained flying into the 1980s, performing search and rescue missions, fighting forest fires, hauling cargo to remote locations accessible only by water. A handful are still flying today, maintained by dedicated enthusiasts who refuse to let the legend die. Isaac Macklin Ladden died on January 14, 1976, at the age of 81. He lived long enough to see his Catalinas become legends, to watch his liberators fill museums around the world, to know that his contributions to aviation would be remembered for generations. He never sought fame or public recognition. He was an engineer at heart, most comfortable at his drafting table or walking the factory floor watching his designs take shape in metal and fabric. He measured success not by headlines or awards, but by whether his aircraft accomplished their missions and brought their crews home safely. By that measure, Isaac Ladden succeeded beyond anything he might have imagined when he first sketched a flying boat that could cross oceans. Flying Officer Dennis Briggs of the Royal Air Force continued flying with Coastal Command after the Bismarck mission, earning both the Distinguished Flying Cross and a bar for repeated acts of bravery in action against the enemy. A recording of his interview describing the moment he found the Bismarck is preserved in the Royal Air Force Museum, a voice from history explaining how a slow-flying boat changed the course of a war. Ensign Leonard Smith received the Distinguished Flying Cross from the United States Navy for his role in finding the Bismarck, though the award had to remain classified for months because officially America was not yet at war. He went on to serve throughout the Pacific in the years that followed, fought in Korea and the early stages of Vietnam, and retired as a Navy captain after more than 4 decades of service. He lived on San Juan Island in Washington State until his death in 2006 at the age of 90. The Catalina that found Bismarck, aircraft AH-545, did not survive the war. Like so many of her sisters, she was eventually lost to the hazards of maritime patrol operations over the unforgiving waters she had served above. But her legacy endures in every maritime patrol aircraft that followed, in every long-range search and rescue mission, in every design that prioritizes endurance and reliability over raw speed. They said his flying boats were obsolete. They said the age of the seaplane was ending before it truly began. They said slow, ungainly Catalinas had no place in modern warfare where speed was everything. And then one of those flying boats found the Bismarck when the entire Royal Navy had lost her. In a single morning over the gray waters of the North Atlantic, an aircraft that the experts had dismissed proved that it could accomplish what nothing else could. The skeptics were silenced. The critics were proven wrong, and a legend was born in the spray and clouds above the waves. Trust your judgment when you know your work has value. Build for the mission you actually face rather than the mission that impresses critics. Sometimes the slow and steady approach is exactly what the moment requires. The experts are not always right. History remembers those who delivered results when results were needed, not those who chased the latest trends. That was the lesson of Isaac Ladden. That was the lesson of the Catalina. That was the lesson of finding the Bismarck when all seemed lost. Isaac Ladden understood something fundamental about engineering that extends far beyond aircraft design. The best solution to a problem is rarely the flashiest one. The most important innovations are often invisible to those who measure progress only by speed records and altitude achievements. True engineering genius lies in understanding what the mission actually requires and building something that accomplishes it better than anything else in existence. The Catalina was never the fastest aircraft in the sky. It was never the most maneuverable or the most heavily armed. It was simply the aircraft that could be where it needed to be, for as long as it needed to be there, reliably and repeatedly, and without fail. When that mattered more than anything else, the flying boat that critics had dismissed proved itself irreplaceable. The lessons of Ladden's career extend far beyond aviation. Every field has its skeptics who dismiss proven approaches in favor of the latest trends. Every industry faces pressure to chase novelty at the expense of reliability. The story of the Catalina reminds us that sometimes the supposedly obsolete solution is exactly what the moment demands. The slow and steady approach can triumph when the flashy alternative fails. On May 26, 1941, Britain's survival hung in the balance. The Bismarck could have reached safety. She could have repaired, refueled, and returned to devastate convoy after convoy. The war might have taken a very different course. Instead, a flying boat that the experts had dismissed spotted a dark shape through the clouds above the endless gray Atlantic. They called flying boats obsolete. Then one found the most dangerous warship on Earth, and everything changed.